Welcome back to the deep dive. Today we're getting into a piece of hardware that you've probably never seen, but absolutely rely on.
For sure.
We're talking about the Thor F-EDFA-14 optical amplifier, and our mission is really to understand how this little box solves the most basic physics problem of the internet. Light gets dimmer over distance.
Yeah, that's a perfect way to put it. I mean, think of a data signal as just a pulse of light in a glass fiber. The further it goes, the more it fades. An EDFA, that's an erbium-doped fiber amplifier, is the tech designed specifically to fight that fade.
And it brings the signal back to life?
It restores the light, but crucially, without adding a bunch of noise or, chaos to the signal.
Okay, so this isn't just any amplifier. The F-EDFA-14 is built for channels in the C-band, right? We're talking, what, 1540 to 1565 nanometers?
Exactly. That's the sweet spot for DWDM, dense wavelength division multiplexing.
Which is basically stacking dozens of different colors of light, or channels, onto one single strand of fiber.
Right. And this device is made to boost all of those channels all at once.
Now, what I find fascinating is how it does the boost. It's not like a traditional repeater.
No, not at all. A traditional repeater has to, stop the light, turn it into an electrical signal, process it, and then create a whole new light signal.
And every one of those steps takes time.
A tiny amount of time, but it adds up. It introduces latency. The EDFA, though, it skips all of that. It amplifies the light while it's still light.
So if a repeater is like a runner stopping at a checkpoint to read a map, the EDFA is more like them just getting a sudden, powerful gust of wind at their back?
That is a great analogy. Yeah, it's just a continuous push. And that gives you the key benefit here. Virtually zero latency.
Okay, virtually zero latency. That's the term that always makes me a little suspicious. I mean, how much delay are we actually talking about?
It's negligible. I mean, orders of magnitude faster than a repeater. It's so fast that it's the only way you can do, say, transoceanic cables.
Wow.
It's also what you need to feed something like a PLC splitter, where you're taking one powerful signal and splitting it across, an entire neighborhood.
Got it. Okay, let's talk about flexibility. The specs say it's protocol agnostic.
Yeah, and that's a really powerful feature. It means the amplifier just doesn't care what kind of data it's boosting. It's the ultimate utility player in that 1550 band.
So it can be high-speed digital traffic, but I also saw it can handle analog RF over fiber?
It can. High-speed digital, high-speed analog, whatever. As long as it's light in that frequency band, it gets amplified. That makes it incredibly useful.
So looking at the specs, it puts out 14 G-lambs of power.
Which is a pretty serious punch. Enough to overcome many, many kilometers of fiber loss. It also has a low noise figure of 6.3 dBm.
Okay, quick clarification. Noise figure is basically how much static or fuzz it adds back into the signal it's boosting.
Precisely. And 6.3 is an excellent figure for this power level. It means the signal stays incredibly clean, which is critical.
And it seems that focus on quality extends to the build, too. They talk about a high-quality pump laser and OFS erbium-doped fiber, and they specifically call out that the fiber is made in America.
Right, and that's not just marketing. In this industry, when you see a specific component origin like that, it often points to much tighter quality control standards.
The kind you'd need for really mission-critical stuff.
Exactly. Defense contracts, high-security data centers.
Yeah.
It signals a higher level of reliability.
And for the people managing the network, it has remote management, right? RS-232 and SNMP.
It does. So you can monitor and control it without ever physically touching it. And there's a neat safety feature, too.
Oh.
Yeah, the front panel has a warning alarm that automatically shuts off the pump laser if there's no input signal.
Ah, so it protects itself from burning out. That's smart.
Protects the most expensive component, yeah.
So to pull it all together, what we have here is not just a booster. It's a critical engine for making the modern internet scale. It enables everything from those huge intercontinental links to local fiber networks.
And it does it all with almost no latency. So I guess if we connect this to the bigger picture, it really raises a question for you to think about. What part of our connected world, from your video calls and streaming movies to global financial trading, which of those things is not completely dependent on that promise of near instantaneous information transport? It's something to think about next time you're on the information highway.